What's going on, kids? Today we're going to take a look at the Electude simulator for diagnosing a dead battery or trying to diagnose a no crank, no start condition. So you turn your key and nothing happens. This is going to be pretty much the same thing that we did in the other video on a live vehicle, but just in the simulator for while you're working on cars at home or while we're in remote. On the left here, we've got our work order, and we can see the date that we are doing the job. We've got our vehicle identification number, and then your name is there. So it's there on the assignment when you turn it in. This kind of mimics what we have in the real world, where a vehicle comes in and the customer will tell a service advisor kind of what's wrong with the car and what it's doing. And then that service advisor or service manager is going to write down the customer's complaint, and they are going to be the kind of go-between between the technician and the customer. So it's your job as a tech to read that information and try and figure out where you're going to start. And the first thing that we're always going to do is verify that complaint. So what happens when we start this car, and then we can start our diagnosis. As you're performing the work, it's important to write down what you're doing, because as a technician, that's how you get paid. You have to diagnose a vehicle in a certain way using a certain procedure, and you have to show that you've done those diagnostics in the right order and in the right way in order for you to get paid on Friday. So this is where you're going to type out the steps that you're doing kind of as you do them. I am not going to do that just for the sake of this video because you don't need to see me type. And then there's a checklist here for the activity where did you resolve the failure? Did you verify the repair when you were done, which is incredibly important? And then, did you do the diagnostic work, like pull the check engine light or pull the codes and all of that when you were done? All right, so let's take a look at our tools that we have to work with. So over here on the left-hand side, we can drag out this menu, and we have an instrument panel. That's going to be how we start the car, how we can rev the engine. If we were diagnosing other issues with the vehicle, we have a battery light, which we'll look at, an oil pressure light, check engine light, as well as temperature gauge. We're also going to need a multimeter for this, which is kind of similar to the one that we used in that other lab. It doesn't have the same functionality as a full-blown automotive meter, but this is good enough to get the job done for what we need to do today. We've also got a jump pack, and we'll also be using a scan tool today. And we'll talk about the invoice a little bit later. All right, so first thing we need to do is verify the complaint. So let's go ahead and try and start this car and see what happens. So I grab my ignition switch, go to the on position, and then I'll try and start it. And we get a whole lot of nothing. So let's see what happens when we try and start this car and why we have a whole lot of nothing. So I'm going to zoom in on the battery here, and if you're on a PC, you can use your mouse wheel to scroll. Otherwise, if you're on an iPad, you're going to want to use this kind of icon up here in the corner to zoom in and out. If you're using an iPad and you're using like the pinch to zoom function, sometimes it'll zoom in with the app like Chrome or Safari instead of with this module. So you want to use this over here. And once I've zoomed in, I can then grab my negative lead on my meter and put that on the negative post, and I can grab my positive and put it on the positive post. If you flip these, the voltage reading you're going to get is going to be negative because the meter's seeing the inputs come in the wrong way, so it'll give you a negative voltage number. If you see negative voltage, it's okay. You didn't break anything. You just got to flip your leads around. So we're going to grab our dial on the meter, and we're going to move this over here to 20, which is going to give us two significant figures here for our voltage value. And we can see our battery voltage is 9. Well, that seems good, right? I'm sorry, our battery voltage is 12. That seems good. Batteries are supposed to be 12 volts, so this is a good battery, right? Well, no. Let's see what happens when we actually try and start the car. When we put a load on this battery, what happens to the voltage? When that current starts flowing out, what happens to the pressure inside of this battery? So we'll key this thing on, and we notice immediately as soon as we turn on our accessories, which would be the radio, the fan, headlights, all the computers wake up, our voltage automatically drops. And it drops a fair amount. It drops all the way to a little over 11.5 volts. That's significant for a battery. You should still be well above 12 volts when you key on your battery. There should be enough juice in that battery to run things like your radio without having such a large voltage drop. All right, so now let's start the car, and also keep an eye on this number as I try and start it. We don't have the same ability to put the min-max record on this meter like we do on our 504 meters that we have in the shop. So we're just going to kind of look at that and try and remember the lowest number that we see. So I'm going to turn this on, and as I'm trying to start it, we see nothing happening. The car does not start, and that's, I don't know, 7.5-ish, I would guess that kind of looks like. So our voltage drops all the way down to 7.5 volts. That lets us know that there is too much resistance inside that battery. The battery cannot push out enough energy. So that is a battery failure. Normally, I guess if you're in the shop, you'll be able to use a battery tester and read the cold cranking amps, how much potential energy does this battery have. But in this kind of module, we don't have that ability. All we can do is use the tools that we've got, and that tells us that the internal resistance of this battery is way too high. There is a fault inside of this battery that cannot be repaired. So it must be replaced. In addition to the battery being bad, let's make sure it's maybe not an excessive draw someplace else. Let's make sure it's not our starter motor. So we can grab our jump pack and throw a jump pack on here, and now we see our voltage jumps all the way up to 14 volts. That's your charging voltage. That's what you would normally see when the alternator is running. Remember, the alternator is the thing that kind of refills the bucket for us. It puts the water back in. It refills our battery as we're pulling energy from it. So let's see what happens when we try and start our car with the jump pack on. So I'll turn it off, go back to the on position. So again, we're at 14 volts in the on position, not the 11.5 that we saw before. And I'll try and start the car, and let's watch our voltage and see what it does. It only dropped to 13.06 volts. So without the jump pack, a good battery, the voltage dropped all the way down to 7. With a good battery, our voltage only dropped 1 volt. It went from 14 to 13, not 12 all the way down to 7.5. So that, again, lets us know that it's a problem with the battery. It's not a problem with the starter. It's not a problem with the wires. It's not a problem with our connections, right? We always want to do a visual inspection first. This test lets us know that the problem is in fact with this battery. So we can put our jump pack away, we can put our meter away, and now we need to swap out this battery. So I'm going to click on these leads, and you'll see they pop off of there. And as I drag my mouse over the battery now, there's a highlighted box around it. And I can grab the battery and drop it down here to remove the old part. And then if I click on it, I can replace the part. Click replace, and then I have a yellow kind of corona around that battery. So I can grab it and drop it back into place, slap my leads on it, and test my voltage now again with our new battery to make sure this new battery is good and this new battery is charged. We are verifying the repair. You always need to make sure that the car is in like new condition before it goes back to the customer. You never want to return a vehicle if you haven't fixed the problem or if you've created a new problem with the vehicle, right? We want to chase down every single thing that may have caused this issue. So we'll check our voltage again. We're at 12 volts with the vehicle off. That is fine. Let's key it on and see what our voltage drop is. So now with our accessories on, we're still above 12 volts. That's what we want to see. There's enough juice in this battery to let the car run. So we'll try and start it. Let's put the load on this battery now and see what happens. We saw it drop to 11.5 or somewhere around there, and then now we see that voltage jump up to over 14. That 14 volts is the charge coming from our alternator. Our alternator is pushing current and voltage, I guess, to our battery to make sure that it gets replenished from the energy that it used to start the car. We can do a real quick test on this battery to see if the alternator is what caused the battery failure. We'll get into this more when we get into alternators, but alternators actually generate AC current, which can damage a battery. And we can just do a quick test here and flip this switch from DC, this symbol here, over to AC, and see if our meter can detect any AC voltage going to the battery. We have zeros, so none. This is the AC ripple test that you saw in the other video, or that you will see in the next video with the digital storage oscilloscope. But yeah, so alternator's in good shape. Alternator's pushing 14 volts DC. There's no AC coming from the alternator. We are in good shape. And we need to put our meter back. We can turn off our vehicle. And now we have fixed the problem, right? We fixed the mechanical problem. But modern vehicles, with modern vehicles, there's an extra step when it comes to electronics. Every single piece of electronics in your car, whether it be a sensor, a relay, they're all kind of regulated and watched by a computer. And if the computer sees weird information, it throws codes. And some of those codes are active, where it throws up the check engine light. If it's a really bad one, it'll flash your check engine light, like knock. But sometimes it just remembers something weird that it saw. And it's not a major emergency, but it still stores that information. As a technician, we need to go in and double check the computer to make sure it doesn't see any issues anymore, and then also wipe its memory so that it doesn't keep thinking about those issues, I guess. So we are going to grab our scan tool next, and we need to key our vehicle on. So put it to the number 2 position. It doesn't need to be running, it just needs to be keyed on, and then we're going to identify the vehicle. We need to have the computer ask the car what it is so that it can speak the same language, so it knows how to read the information that it's given. And then we'll go to all fault codes. And as we read these fault codes, they all have to do with low voltage or communication errors, right? The computer can't talk if it's off. If the voltage is low, it can't do anything. So that's what all of these are related to: lost communication, circuit low, lost communication, circuit low, system low voltage. All of these things point to a battery or alternator issue. Our alternator's fine. We tested that, kind of. Our battery was not fine. We tested that, and it tested bad. So now we're going to clear these codes and make sure that we don't get any more codes that pop up immediately. If they are a hard failure, a hard code, with communication or sensor failure, whatever, those codes should pop up pretty quick. That didn't happen, so we're in good shape. We can turn our car off, turn it back on, make sure we don't have any active codes, right? There's no pending codes, and we can put our scan tool away. Turn the car off, put our instrument panel away, and now we need to make sure we go through and complete this diagnosis work performed. So just type out what you did. I'm just going to put fix the problem. Please be more specific than that. Say how you fixed the problem, right? And then we've got the checklist. Was the failure resolved? Yes, it was. Did I verify those repairs? Did I make sure the car started? Yes, I did. And did I do the diagnosis work? Did I plug in the scan tool? Did I clear those codes? Did I make sure everything was actually ready to go back to the customer? Yes, I did. And then you can return the vehicle to the customer. This is the equivalent of handing it into your teacher. The other thing before I click that button I want to show you, there's an invoicing system in here as well. And you'll need to take a picture of this. So I'll show you the screenshot that you need to submit. But this has a breakdown of what this job cost. So it was $150 for a battery. It was $30 to hook up the scan tool, and then they assign $1 per minute, I believe is how they work this. You just saw it go up another $1. So the more time it takes you to diagnose a car, the higher the invoice is. Now that's not really how it works in the real world because there's book time, but this kind of gives me a way to assign a project where you need to show me that you did this job for, let's say, under $210, which means you would need to know the process and know this diagnostic like the back of your hand, so you can just knock it out. So I'm going to return this vehicle to the customer now that I've done everything, and then I get a green check mark that says the failure was resolved. Now, if I forgot to do something like clear the codes or put all of my tools away, or if I had replaced a part that I didn't need to replace, they would also tell me that in that little box. So now we've got our issue figured out. We can do all of this in simulation, and you can grab a screenshot of this, put it in your assignment, the PDF using Notability, and then submit that in school as Unity assignment. If you have any questions, you can always shoot me an email, ask me questions in class. Otherwise, be good, and I will see you next time.